Hi, welcome to Dr. Pat TV. We're looking at annuities, loans, retirement savings, all those kind of fun things. And basically, the idea here is we're saving up for the future and paying off the present. So just kind of keep that little phrase because it's actually going to hopefully make sense later on when we look at the formulas. Saving up for the future, paying off the present. All right, so some definitions that we have that we're playing with: annuity, sinking funds. Okay, basically it's a series of equal and regular payments that we're building up a balance. Annuities are offered by insurance companies. Sinking funds is the general kind of the term. And so the key thing there is regular payments, equal regular payments. Unlike our savings, our certificate of deposits from before, we deposited the money and then we just left it. We walked away, left it, came back at the end of the time. Here, we're making regular payments. With annuities, you have different types. You have an ordinary annuity. That's basically you're making the payments at the end of each month. That's normally what we have. And then you also have something called annuities due, and those are when the payments and the interest is calculated at the beginning of each period. You can see that in your calculator if you're using the TI-84 or 83, the little finance feature, the TVM solver. It actually has one of the lines where you do beginning or end. And so this is where the case is, depending on the annuity, you might have to highlight end or beginning. And then basically the future value of an annuity, that's the amount that you have at some future date. It's the ending balance. Basically, remember, it's the total combined of your payments and the interest. So future value is the payments and the interest combined. Now, here's the formula that we have, the formula that we're seeing here for our calculations for sinking funds, for annuities of those types. When we're making regular payments, that's why you're seeing PMT. PMT's payment, those are our regular payments. So basically, we're doing equal payments, monthly, weekly, semi-annually, those kind of things. Quarterly, doesn't matter. That's what we have. And then we have a part of the formula right here. You might be wondering, whoa, where did that come from? Well, that actually comes back over here to the left. Here's some mathematics that's showing where that formula comes from. And basically, you're seeing this addition of a 1 plus r, and you have the different powers here. So the third term here would have been 1 plus r to the third power, and so forth to the n power here. It's nice. It's good, some cool mathematics that it's been done here. And so basically, if you want to look at that, take a look at this. We can talk about this at another time. So I just wanted to let you know that the recurrent payments are, the interest is calculated on the recurrent payments. And so what each of these little guys here is the calculation of the future value of that recurrent payment. And of course, time multiplied by 1 plus r. So basically, this is the start of it. All the payments that you make and the interest earned on the payments all added together, and then the mathematics that happens to convert this long series of payments into a nice straightforward formula. So that's what we have. Your I is your interest rate per period. So you also have seen that as R over M sometimes. Basically, that could be a fraction there if you've given a rate, an annual rate, and then you have to cut it in terms of the periods per year. N there is the total number of payments. And once again, that's also could be construed as an MT, the compoundings per year times the number of years. So those are the modifications you could make on this formula. And then when you do all that calculation, you get the future value. So this is all about adding up each of your payments and the interest for each of those payments, and you add them all up together and you make this nice formula. Okay, so let's do an example of this. What's the future value of $25 deposited monthly for 30 years at a rate of 2% compounded monthly? Okay, so we're making monthly deposits. We're compounding monthly. We're going to do this for 30 years. So what information do we have? Our N is going to be 360 because we're doing this 12 times a year for 30 years. So 12 times 30, 360. We got our 2% rate, and then we don't have a present value because there was no an additional amount deposited in the beginning. It's just the regular payments, and our regular payments is 25. And then our compounding and payments per year is 12. So this right down here on the bottom of the screen here would be how I would type it into my calculator. If you're using the TMV solver, these are the information that I would have, and then I would move my cursor to the future value line FV and then do your alpha solve. If you're using the formula, this is the setup of your formula here. And so I'm doing the 0.02 divided by 12. You can do these on the side kind of things and bring them in however you want to play that. And then the 12 times 30 for the 360 payments there you see in the power. When we crunch this out using either the calculator or the formula here with the calculator, by the way, we're getting 12,318.14. And so there's an example that we have for a sink of none. Now, one question that we'd probably all want to know is, hey, how much interest did we earn on this? Now, the key thing here is we've been making regular payments. So when we look at our future value, how much we ended up with, remember that the future value was the total payments plus the interest. So if we take out the total payments, then we have left is the interest. So interest is the ending balance minus our total payments, because the ending balance has total payments and interest in it. And so that's what we do. We ended up with the 12,318.14. We're going to subtract out our 360, because that's what we get here, 30 years, 12 times a year, 360 payments of $25. That turns out to be 9,000. So you take out the 9,000 and we're left with 3,318.14. And so that right here represents the amount of interest that we have. Okay, so that's the start of this annuity sinking funds idea. I've got some more examples coming. Take care. Have a good day.